I would like to say thanks for this Web Rebels. That was me at the first Web Rebels 2012, where I started public speaking. I started to speak at conferences, not for me, but for viewers to try and give something, and hopefully what I experience can improve other people's experience. Here's Vida, my daughter. She's 7.5 years old. I always sneak her in my talks. She loves nature and all things technical. Since this year, I started to run a code club at her school. We have about 20 children from elementary school. They are 7 to 11 years old. Recently, we're using the Pico 8, which is a fantasy console, and they really like to learn and to create new things, and it's really fun to see them. Whoa, super happy about it. And yeah, hopefully one of these kids will join Web Rebels and talk about what they are doing. With that, my name is Mathieu Henri. Online, you can find me as P01. I work for Microsoft since a bit less than 2 years. It's a pretty amazing company. Previously, I was at Oprah with Patricia. And at Microsoft, I really found nice challenges and a really professional team that really takes care of what we're doing. My team works on the profile card. This is the card that you see on the left-hand side. It's shipped in all of Office 365. This is a third-party component. It's a third-party component in Microsoft land. It is built by my team and a couple of other teams, but it's only consumed by Microsoft. It's a third party in the sense that it's consumed in many workloads, in many websites built by Microsoft. So it really behaves like a third-party component. We have over 50 contributors. We support IE11 and all the evergreen browsers. Because we ship in many workloads, we have to have some host app integration. Like when you click the send email button, if you're in Outlook, you should use Outlook to send email. If you're in another workload, you should launch another experience and these kind of things. We do weekly deployment, and the card exists in two forms. The small form that you saw initially, which is what you see first anywhere in Office 365, and you see a person. You can hover that person or click, and then you get this small card with information about what is your relation to this person or this entity. And once you click through, you actually drill through and get a more broad view with more information. So I did not come to sell you a framework, or I came here to tell you about our testing story. You might think that testing is a solved problem, and maybe you have seen talks about it. I have watched many when I was trying to test this application, but none of them really apply to our scenarios. How do you test a third-party component? How do you test when you're actually not in your own land, when you're the only person building your application, when you actually integrate with something else? That is not simple. So we'll do this in 3 acts. The first act was about setting up the service. So we started in one workload with very little integration, with 2 teams, one working on the small version of the card and one working on the bigger version. Our tech stack was NPM and Webpack, React and Flux, and we used Typescript. But our goal initially was, there was already such a card in this workload. It was built by my team previously. It was a first-party component, so it was part of a repository of this workload. And we saw some value in having a coherent profile card, a coherent view of a person or an entity across all of Office 365. So our goal was to build a third-party component that could be reused everywhere else. So we wanted to replace this first-party component. We had to set up a service, including some monitoring, build features until we reached feature parity, and were able to replace the first-party component and move forward. we had then to design our testing and quality strategy. So you saw that we use TypeScript, and having this is a JavaScript application. It's web, but using TypeScript gives us strong typing. It just makes sure that all the interfaces and signature of the methods are correct. You just cannot get that wrong, and this is great because as you write code, VS Code and the compiler tells you immediately that this is completely invalid. You are passing wrong arguments, or you're using the class in a way that is not expected. That way, you don't have to care about this silly mistake, these small mistakes, and you should not have to. You should only care about logical bugs. These are the real thing where you should spend some energy. And to cover some of these logical bugs, of course, we have unit tests. We run them in continuous integration, and it's really an easy way to get coverage of the basics of all the util functions and how some slightly complex functions behave. So you want that covered, and we do that on CI. And the card, this profile card, is run as a service. So we do have some monitoring, and it's really crucial to run the service. It gives us real-time quality of service for all the endpoints, for all the data calls, all the clicks, and if something breaks, we can see within minutes that when people click somewhere, that it actually fails to respond by 2%, and then something is going wrong, we have to look and investigate. And we do get alerting for all these monitorings, which is absolutely crucial to run the service. And because we do weekly deployment and we have all this monitoring in place, we initiated a shield rotation. We are 8 people in my team, and we set up this shield. The shield is one developer, which every week or every second week is in charge of shielding the rest of the team so that they are able to do feature work. And the shield looks at service review, the quality of service, all the alerting, and if there's an alert that fires off, the shield will run some investigations and eventually roll back if necessary. And the shield will also drive the sign-off. The sign-off is really when we look at a build and test it all the way through and give it a go-ahead. And for this sign-off, unfortunately, we are doing manual sign-off in 5 browsers, so i11, Safari, Firefox, Chrome, and Edge. And it's not fun, but that got us there, really. We were just starting. And actually, it was okay, because then we were really setting up the service, and we were working in a very confined environment. The main issues we were facing was about quality of service, because we were setting up all the endpoints, performance of these endpoints, and functional issues when we were building features. So this approach, even though it was not really fancy, it allowed us to reach our goal. And it allowed us to reach our second act, which was when we did take off. So we started in this one workload where we were trying to replace the existing first-party component, this first-party profile card. And at this point, we managed to ship and reach 4 workloads. We had a bit more integration, so things like email integrations. We could pull emails from Outlook when you were in Outlook to see all the emails that you sent with a person or this person sent to you. And also, when you click this send email button, that you would compose email through Outlook and this kind of things. We also grew to 5 teams working on different aspects of a card in different versions. And technically, we switched from NPM to Yarn because of some issues we were facing with browser-specific modules that were optional per platform, and it was really annoying. It was messing up with all our modules and our dependencies. And we switched from Flux to Redux, and we started to use Fabric UI, which is a UI framework from Microsoft to build that builds components used in all of Office and Office 365. That gives us really cohesive design, and also it gives us accessibility for free in many components. So then our goal was to deploy the card to more workloads, improve the service, and add new features. So we had to think about additional testing and quality measures. So we moved from Flux to Redux. Flux is a unidirectional model, and Redux, well, I think you all know, you just have one store, and you can update the store, and store updates are reflected on your UI. And this is really great because that way we could actually get snapshots of the stores and load them to reproduce a bug. And with the Redux DevTool, we could do time traveling to actually roll back in the actions in the card if a customer or an internal user reported an issue. And that way we could really go back in time and say, okay, when you switch from this, when you got data from this action, things went wrong, and okay, now we can correlate that to the code. We also started to use Jest snapshots for our components, and we run them in continuous integration. Jest is really interesting because it gives you snapshots of your components, and you see really what changes, and you can validate if it's expected change or not. But as we were building the profile card and we were really like implementing things continuously, these snapshots, they were changing all the time, and we have not seen so much value in them. But we keep them, and they are still useful, but they didn't have the impact we were expecting. Another great thing that we used was because we talk a lot with our backend team, which is like literally sitting next to us, and they set up all the REST endpoints with Swagger. They describe all the REST endpoints with Swagger, and we could reuse Swagger to generate the code for all the data model on our data layer. That way, when the data models change or the REST endpoint change on the backend, we can just run a command and just generate all the data layer, and we have 11,000 lines of code generated for free. And if you find a bug, fix it in the template, done. It's really a lifesaver. Yeah, and at this stage, so I said that we were taking off and reaching more workloads. We realized that yeah, with more workloads, our test and integration metrics just exploded. The Shield was running the sign-off and doing manual sign-off in one browser, in one workload, but we had about 50 tests. Now we were in 4 workloads. We had about 50 tests and 5 browsers to test, and it just exploded. So we had to spread the manual sign-off so that it was not one person going insane for one day. We had to spread it. We tried to spread one developer will run all the tests for one workload, but on all the browsers. But switching browser was too disruptive. You also had to switch to a Mac if you to test in Safari, or from a Mac to Windows machine. So we decided to split per browser. One developer takes one browser and tests all the workloads, all the tests in this browser. Yeah, still not great, but that's the best we had at the time. And also, because now we were shipping not in one workload, but in 4, we saw that with more workload, we came visual regressions. When we were initially in one workload, we knew everything about the DOM, about the CSS, the order of the CSS, how they are loaded, and everything. But now that we were in more workloads, we had no control on any of that. So for instance, here's the organization chart. So you see how it should look like. I just redacted the names. So you have a picture of people, and right next to it is their name, their title. So, but here's what we saw recently in another workload. The photo of a person were in display block, pushing everything down. And also here, you might see that the picture of a person is a bit shorter than the circle. It's inside. And here, the text boy, which is a text representation of a person, when it does not have a photo or the photo is not loaded yet, it's cropped in a really weird way. This particular issue happened because we bumped a version of our UI framework, which loaded the styling sooner, and then the workload was injecting its own style a bit later and overriding some of our classes. They shouldn't. Yeah. That's what happens when you use global style names, and but we are moving away from that. So we really had to look at automated visual testing. We couldn't look at all these issues by hand. So we had to look at all the options. Yeah, there is Selenium. When you look at automation, you cannot escape from Selenium. But if you have touched it ever, you know that it's a bit flaky, it's a bit slow. You often get false positive or negative, and it's a big hassle. And the tests are also, because they are flaky, they tend to fail for unknown reasons or timing issues. Very expensive to maintain. The new kid on the block is Cypress. It's an amazing tool. It's been built since about 2 years, and it's Chrome only. It is targeting React applications, and it's extremely fast, extremely powerful. It can even take videos of all your tests as they are running, and you can save them, and that way you can give them to, when you onboard new developers, you can say, hey, here's a video of how the application works. Just play it in slow motion, and you also see the test. But we have seen browser-specific blockers, and we could not go with something that only worked in Chrome. The next thing that we looked at was the Chrome DevTools protocol. It's super powerful, and it's kind of Chrome only. It's not just in Chrome. There are bridges to support the Chrome DevTools protocol in the other browsers. There are bridges for IE, for Edge. Firefox has some issues to put it under a map and support it. I don't know the status yet, but yeah. So we went on and started to write automated visual testing using the Chrome DevTool. And for that, because I wanted to make sure that I can move forward and that I don't marry a framework or an approach, I did something ad hoc. And I made a small testing framework, which opens a tab in Chrome with a workload, with any of the workloads that we ship in, passing a specific version of our component. We inject the test library and the test specifics to that workload. They run. They send some commands to take screenshots and resume the test and so on. And then that way we can run all our 50 or 100 tests in any workload just by command line. And we get a bunch of screenshots. So it's great, but we need to look at them. And for that, we used, to look at what changed, we look at a library or node module called Pixel Match from Mapbox, a big mapping library or mapping company. And this is what we got from Pixel Match. So here, you see a comparison of the difference of two versions of a card. And you see very pale, all the pixels that did not change, and in bright red, everything that did change. And that was a huge step ahead. That way we could run tests in all our workloads in Chrome and see everything that did change. So that really allowed us to move forward. With that, we were able to stop signing off manually in Chrome, so we cut down our manual sign-off to 4 browsers. We had visual regression technique, and it was a lot easier to onboard partners and new workloads. Because then we had a framework to write tests and to see when things break. It also served as part of a functional testing. So it was really, really useful. It really allowed us to move forward. And that brought us to the third act, where we went up and up. So at this point, we were in 4 workloads, but with visual testing, we were able to move to about 16 now. with more and more integration with all these workloads to support scenarios that make sense in them. On the tech stack, we just added Lerna. Lerna is a tool to manage multiple packages because we were so many teams building different packages for different environments. We had to, well, using Lerna made everything a lot easier. The goal was to deploy the card even further to more and more workloads, and at this point, because it became easy to integrate the card and get a coherent experience for all these profile, to view the profile of an entity in Office 365. Now, we did not have to come to the different partners, to OneDrive and SharePoint and Outlook, to say, hey, would you like to get the card? Now people were coming to us and say, like, how can we get this profile card? How can we get a coherent view of all the people or the entities in our workload? So it was really nice. We were able to do this. And then our goal was really to improve the service, make sure that things work good, to add service features, make sure that the performance are good, and improve also UI performance, and made the onboarding even easier. So there was one big piece that is missing. That was cross-browser automated visual testing. So we looked again at what we can do, and there's no new tool to do it. There's nothing new. So I looked at some old techniques. One approach that I tried was to take this test framework that I did and run it in the client, actually. I tried to make a page that would open the workload with a given version of the card in an iframe, and then send commands over cross-document messaging and do some kind of RPC to run the test in an iframe. Because it runs in the browser, then I cannot get screenshots. I would have to do a DOM and CSS snapshot of the state of the card. It worked in several browsers, but it did not in some others because of really deep architecture reasons, which realistically are not going to get patched. And some workloads have more strict cross-scripting policies. And it was not realistic to put this requirement on the workloads we wanted to integrate us. So that was a no-go. Another thing we looked at was to generate test bundles. I mean, we generate several JavaScript bundles for the card, but we could also generate bundles for a test. Again, because it works in the browser, it would work in the browser, we could not get actual screenshot. We would get just a DOM and CSS snapshot of what is happening. But the integration was really tricky. Like, how do you expose this test bundle? Like, do we expose a global method in the card? And then are we OK to expose all our tests to everybody? That was not great. So yeah, we were a bit stuck. We were not sure. And so yeah, the only thing that really works cross-browser is Selenium and something like WebDriver. So with Selenium, you can make or take screenshots. And it works a bit like the Chrome DevTools protocol. And I can totally replicate what I did with the Chrome DevTools. I can open tab and inject my test library and run the test, send back some commands, take screenshots, and so on. But yeah, that's we still had to run the service to get going with our service and work with people. So we had to improve the automated visual testing, which was in place and running, and it was working. Just that we were getting all these screenshots, which shows the pixel that did change, and it was a huge step. It was really, really useful. But they have no context. You just see that, yeah, some pixel change, and that's not great. When you, so I try to improve on that and to make side-by-side this that would show the visual differences or the pixel that change, but in context. Think of it as a Git diff, but at the pixel level. When you push a commit and look at the diff, you see what you added in green and what you removed in red. And this is what it looks like in practice. This is this side-by-side screenshot. So on the left-hand side is the baseline, so the version that was in prod or the version I am testing against. In the middle is the diff that we saw before. On the right-hand side, yes, always confused. On the right-hand side is the candidate version that you are trying to sign off. And so if you look just at the middle, you see red text that says profile and these chevrons, and it's not really clear what happened there. You just saw that something changed there. But if you look then on the right-hand side at the latest version of the code, you see that there's a faint text in red that says profile. And this red ghost shows that in the new version, these pixels were removed. And it's a little bit harder to see, but on the other side, you can see a faint green ghost just above the R and the O of profile. That shows that pixels were added at this point. So here it's really clear that the only thing that changed, although it's not clear from the red pixels, the only thing that did change was that we changed the string. And that was an expected change. It's clear. Next example looks more chaotic. And if you look just at the middle, at the pixel that did change, you cannot make sense of that. It's just like red everywhere. Everything changed. But if you look at the newer version, the new version of the code, there you see the text and you see a red ghost. I hope it's visible on the big screen. You see the red ghost of the previous version. And there it's pretty clear that what happened, although there are many changes, the only changes are, because this is the LinkedIn section in the card, where you see LinkedIn profile of a person. The only thing that did change here is that we aligned the typography and the spacing to match those of LinkedIn. And it just makes sense, like, yeah, sure, this is completely expected, but if you look just at the diff, this is chaos. One last example is this one. In the middle, you can see the difference of the pixels shows something that looks a bit like a box, and then two lines that go further. On the baseline, you can see that some gray lines were going all the way, and then you see a green ghost that is just a box. And then if you look at the version that you're trying to commit, you see this red box where you can add notes about a person, and you see the red ghost that was going all the way through. And that was a bug. I mean, the text area where you can enter notes about a person was completely messed up. It was going all the way through, and we couldn't achieve that in prod. So here we chose a fix of a sign-up blocker. So we had all these screenshots, like this side-by-side screenshot, and we need a quick way to go through them and validate them. So I built a small page to show them and validate every change. This is what it looks like. So in the middle, you have a side-by-side screenshot. At the top, you have the versions that we are testing, the baseline and the candidate version, the workload, the name of the test, how many pixels change. You can sort by amount of changes, by workload, by test, by rating. And you can navigate with the keyboard and quickly go through screenshots and up or down vote a change to say if you approve, reject, or if it's accepted change. And yeah, that way it's really quick. Like you run the test, they run for 10, 15 minutes in all the workloads. You open this page and you just you quickly go through all the changes. It's really, really quick. So with that and the added confidence we had in our testing, we have not seen blocking issues that were purely in Firefox or in Edge. So we were able to go down to 2 browsers, which was a huge improvement. We had a stronger confidence in our visual regression testing. And the great thing is that because what it does, it opens a workload and then tries to open the card for different types of personas, of entities, and exercise many code paths. It did catch several blocking issues that were not visual. It did catch several things. And the onboarding was a lot easier. So this is where we are, but our story is to be continued. I mean, This is really where we are today. We have type safety thanks to TypeScript. We run many unit tests. We have all the monitoring. We do manual sign-off. We still do manual sign-off in 2 browsers, and we have Jest snapshots. We use the Redux DevTool to travel in time and revert our actions and see what happens. We have the automated visual testing and service monitoring. So this is where we are now, but this is not perfect. This is far from it. It works pretty good, but we can do better. And what is next on my backlog is to move to WebDriver and Selenium to get cross-browser visualization, to integrate with Git and Visual Studio Online so that I can actually map visual changes to Git commits and file issues about all these visual changes that are not accepted or pure regressions. And one thing I really want to add is DOM and CSS diffing, so that when you see a pixel changing, that you can get the DOM and CSS snapshot of the card, so you can relate. Like, when a text changed or moved, you want to know, did it move because something in the DOM moved in the workload, in the code? Does it map to one of your commit? Did the CSS or padding change deep or way up in the cascade, the CSS cascade? Having this information will be extremely useful. And I mentioned some alternatives, but you probably wonder if there are more alternatives. Some teams at Microsoft use a screener, screener.io. The team working on Office UI Fabric, all these components to build UI in Office 365, use a screener. So they use it in their pull requests. Every time they commit and send a pull request, it runs all the tests and makes snapshots of their components. But our scenarios are much more complex. We really exercise deep scenarios with deep integration. And we also had some concerns about the authentication in the card and about the data that we would expose. GDPR was around the way, and we didn't want to mess anything. We really wanted to be in full control of our test and what we expose. And we do some tests in continuous integration, but not the visual testing. And we don't run it in continuous integration because the tests take 10 to 15 minutes to run all the tests in all the workloads, and you still need a manual pass to say that a visual change is expected or not. So we favor the agility and the velocity of the team. It's really cheap to find a bug and revert a Git commit. It's really quick, and there's no problem with that. But if we find a way which is efficient to run visual testing in CI, we are definitely going to do it. So that was just the beginning of our testing story. We made some mistakes, several mistakes, but we learned from them, and we improved the state of testing. We were really able to move forward, to ship to several workloads, and onboard many partners. So I hope this will be useful, that you will pick some ideas from here, from there, and improve your own testing story. With that, thank you so much, Webworkers, for having me. If you have any questions, I'm P01 online, and thank you.
Thank you. Okay, so we have a question.
Yes.
From the audience, and that was, how does the visual diffing work on mobile?
On mobile?
Yeah. Should I have started softer?
Yeah, I'm not working on it, but the part that does the diffing of the screenshots is completely decoupled from the part that runs the test. Same for the part visualizing the test. So the team working on mobile is implementing integrating tests to take screenshots. This is where I will come in. So I will then consume their screenshots and do the diffing, and then we can use it to validate changes. So far it's not integrated, but it is coming really soon.
Yeah. All right. Yeah. All right. So I had a question about the teaching the kids, actually.
Yeah.
Going back to the very beginning, do you teach them about testing and the importance of testing at an early age? Do you prepare them?
Not about testing, but I told them about debugging.
Oh, yeah.
I really
yeah.
did a session about debugging and told them about Grace Hopper and her team who found the first bug. I showed them pictures. They were really happy about it.
Yeah.
And in this session about debugging, I actually gave them a program that had a couple of bugs and I asked them to, like, can you read the code? Do you see anything wrong? And yeah, they understood it. And also in this session about debugging, I asked them to, a classic way to teach programming to children is to ask them to write the instructions to get out of a maze or something like this. So I wrote some instructions trying to get out of a maze with some mistakes, and I asked them to debug that, and then I also asked them to yourself write instructions, but make a mistake and don't tell anyone, and then pass it to your neighbor. So it was a fun exercise.
Yeah.
But I also teach them to, or tell them to not be scared to make mistakes. Like, it's cool. I mean, nothing wrong is going to happen. I mean, especially with children playing with a Pico 8. It's worst case, you will have funny colors on the screen.
Right.
Yeah.
What do you hope the visual diffing world will be like when they enter the workforce? I hate saying the word workforce, but...
The cross-browser aspect is really tough. And it's expensive. I mean, you need to test 5 times or more. But I hope... I
mean, what if in the future all the browsers render things the same way?
Yeah.
I mean, if we have an open-ended, like, what do you hope for the children?
Okay.
Right?
Okay. I just hope that it would be great that when you commit or even when you build, that you get your testing run automatically, get all the screenshots, whatever. In the test framework where we can load the workload with a given version of our component, we can pass the local host build, so we often do that. When we build a feature, we run the automation against localhost, and then we get current state. We don't even need to make a release build and publish it somewhere.
Yeah. I also liked you mentioned in your in the looking at slide about a sort of stack trace for the CSS that changed, that happened, that made this visual diff. Yeah.
Yeah. And, the folks from Cypress are also working on something similar. They want to go even further and get network traces, and I think that would be extremely useful. One issue we saw recently was about the order in which CSS are loaded, because suddenly we were a bit more lazy about loading CSS. CSS from the workload were injected before ours, and then that clashed. So I hope to get these DOM and CSS snapshots so that we can actually correlate pixel changes to like what changed deep in the workload.
How do you get a team to take monitoring seriously in the long term?
We have paying customers. This is Microsoft. I mean, we ship in Office 365. We have 170 paying customers, 170 million paying customers. So when things go down, we notice quickly, and some people notice, and they file customer escalations, and the whole team is on deck. Like, if something goes down, just boom.
Someone somewhere in the world is awake.
No, but
not on your team, but like someone using the.
Also in our team, we have on top of the shield rotation, we have customer escalation engineers, which are here, and the phone is going to ring if a monitor goes up.
Right.
If a monitor goes up, the phone rings, and then contact the feature crew, say like, guys, something is going wrong. Investigate right now.
Yeah.
And we investigate. Depending if this is serious, we roll back to previous version until we get things sorted out, figure out the problem and patch. Or we patch soon. But we look at the monitoring constantly. We get email alerts all the time, and we have different degrees of alerting. So we definitely look at it. And we also ship in consumer. I mean, it's not just for business users. We ship to normal people, but so we have many users. When things go not so good, this is really bad.
Yeah. All right. Thank you again.
Thanks.
Thank you.